So, good day, everyone. The topic that we will be presenting today is entitled When Life Demands Whole Numbers Real Life Applications of Linear Diophantine Equations. This study shows how a mathematical idea can actually help to solve real world problems where the answers must be in whole numbers and not in decimal form. So, we are Mind Crusader, and I am with Mr. Natividad, Mr. Bernardo, Miss Morales, Mr. No, and yours truly, Miss Mendoza. And we all came from BSMA SGA. So next slide, please. In here, we can see the full outline of our presentation. So next slide. This is the rationale of the study. As mentioned earlier, in many real-life situations, we cannot use fractions or decimals. Like, for examples, you cannot assign 2.5 workers to do a task. You cannot also use a 1.5 buses to transport people. And lastly, you cannot raise 3.2 chickens in a farm. So many real-life problems require whole number answers, and that is where this study becomes meaningful. We want to show how mathematics can solve these situations correctly and efficiently, instead of just having a guess. So to start with the discussion proper of this paper, here is Ms. Morales to discuss the problem statement.
So, thank you, Miss Mendoza. For our main research question, it is how can we solve real-life problems that require whole number solutions? There are many math methods that can produce decimals, but life does not always allow decimals. So, our focus is to find a mathematical method that guarantees whole numbers, and that method is what we call linear Diophantine equations. Next slide, please. So, for the significance of the study, this study is useful in different fields. We have business, education, agriculture, and transportation. For the business field, packaging items and product quantity planning is a great application to consider. For education, it is good in teaching problem solving and logical reasoning. For agriculture, having the knowledge to count and distribute livestock and materials will be helpful. And finally, for transportation, assigning a number of vehicles for routes is a good thing to do. So, this study is helpful not only in mathematics, but also in planning, budgeting, distributing, and organizing resources in real life. Next slide is the preliminaries. Here's Mr. Bernardo to discuss this part.
Thank you, Ms. Morales, for that introduction. Now, before we go to the examples, we need one simple idea. A linear Diophantine equation looks like this. Ax plus by is equal to c. But the important part is x and y must be whole numbers or integers, not decimals, or it has no decimal component. And a whole number solution is possible only if the greatest common divisor of a and b divides c. In simpler words, we can only solve the problem if the total can be shared fairly using the given group sizes. Next slide, please. Now, for the procedure in solving the linear Diophantine equation, so we don't need advanced mathematics here. And the process is check if the total can be divided fairly using greatest common divisor. Next, find one possible solution, then adjust values if needed, and then choose the solution that makes sense, meaning no negative quantities. This avoids guesswork and gives exact whole number results. To start the application process, here's Mr. Natividad having to discuss applications 1 and 2.
Thank you, Mr. Bernardo, for explaining how this part is going to be done. To start in this business example, suppose the store earns money by selling two types of packages. Package A costs 7 pesos each, and package B costs 11 pesos each. The total amount earned is 100 pesos. So our equation to be used will be 7x plus 11y equals 100. To solve this, we think in terms of trial, but in a controlled and logical way. We look for the whole numbers that make the equation true. If we try 4 packs for 11 peso type, that gives 44. Then we subtract from 100, it gives us 56. Now we check how many 7 packs makes 56 by simply Dividing 56 by 7, it will give us 8. The solution will be 8 packs of 7 peso product and 4 packs of the 11 peso product, meaning the store can reach exactly 100 peso in sales by selling 8 cheaper product and 4 more expensive product with no extra money left over. This avoids guesswork and helps in pricing and packaging decision. For our application 2, we will be in transportation example. The goal is to provide 475 total passenger seats. And here we have two kinds of buses. Line 1 buses seat 40 people each. Line 2 buses seat 55 people each. For our representation of equation, it will be 40x plus 55y equals 475. To solve this, we look for a combination that fits 475 exactly. If we try sending 5 line 2 buses, it gives us 5 times 55 equals 275. Subtracting it in 475, it gives us 200. Now, see if 200 is divisible by 40. 200 divided by 40 is equals to 5. So the solution will be 5 buses from line 1 and 5 buses from line 2. Meaning, to transport 475 passengers efficiently, the company should dispatch 10 buses in total, 5 of each type. This ensures no wasted fuel and no stranded passengers. And to end our discussion for the application part, here's Mr. No to discuss the last one.
Thank you, Mr. Natividad. For our final application, let's imagine we're visiting a farm. We know two key facts about this farm. First, there are 100 animals in total. And in second, if we count all the legs, we will get 300 legs. Now, the animals on this farm are chickens and cows. We know that chicken has two legs and cow has four legs. The question is, how many of each animals are there? We can't have half a chicken or two-thirds of a cow. We need them to be whole. So, to solve this, we can get two simple equations, which is the first one is for the total number of animals, which is x plus y is equals to 100, where x is the number of chickens and y is the number of cows. And the second equation is for the total number of legs, which is 2x plus 4y is equals to 300. So next slide, please. Now, to solve this by step, we will, let's imagine first a scenario where all 100 animals were chickens. So if there were that case, we would have 100 times 2 legs, which is equals to only 200 legs. But the farmer told us there are 300 legs in total. So we have the difference of 100 extra legs that we need to account for. So where do these extra legs come from? It's from the cows. Every time we replace a chicken with a cow, we will gain two extra legs because cow has two more legs than a chicken. So to get 200 legs to 300 legs, we need 100 extra legs. If each cow provides two extra legs, we will simply divide 100 by 2. So which gives us a 50 cow. So next slide please. So if we have 50 cows, the remaining animal must be 50 chickens. So 100 animals minus 50 cows is equals to 50 chicken. So in the final answer, with chickens having 50 and cows having 50. Meaning of this, there are 50 chickens and cows. Math allows us to count animals even when we only know its total. So in the next slide, we will be having the conclusion. So next slide, please. So, to conclude our presentation, we've seen that linear Diophantine equations are not just abstract theory, they are deeply practical tools. So, they provide a reliable way to solve real-life problems that require whole number decisions, just like counting animals on a farm. By using this method, planning and allocating resources becomes easier, more accurate, and efficient. So, it's important to remember that mathematics is not just the number on a page. It's a powerful tool for smart decision making in business, agriculture, and everyday life. So, lastly, we will be moving on to Miss Mendoza.
Thank you, Mr. No. Before we end, I would like to take this opportunity for you, the viewers of this video, to come and take a look and read our written output for better understanding of everything that we've just stated earlier. Next slide, please. So, just like what Leopold Kronecker said, God made integers, all else is the work of man. Once again, thank you, and we hope that you learned and understood something new today. Until the next time!